second session on data processing. The data processed for additive manufacturing process will start with the CAD modeling. CAD model saved in STL format. After STL file, you can do a part orientation. Then based on the part orientation, structures are generated. Part along with the support structure is sliced into n number of. Then after slicing, for each of the generating the into part, then parameters for STL to part will transfer to machine for part fabric. Then after printing, post processing done to remove and to enhance the finish of the comp. So in this lecture, we are going to second step in data processing, STL file generation. So why the STL file required for additive manufacturing? How the STL file format is helpful for additive manufacturing and what are the issues or defects behind in STL file and how to address those. So these are the content which will be discussed in this lecture. So say shown here, there is a sphere and you can see multiple spheres. This sphere forms tessellated. That is the surface, the curved surface of a sphere are converted into a patch of triangle like a face. As a number of triangle increase, accuracy also increases. Even at higher number of triangle, we cannot get same as what we have modeled in a CAD, but still, if you keep on increase number of triangle, that will improve the accuracy. So this is one typical example how the STL file look like. So STL file is nothing but a conversion of your surface into connected faces and the shape for each face a triangle shape. So that is the reason the STL file, so abbreviated as stereolithography format, which is a de facto format for additive manufacturing process. And it is also named as standard triangulation language. That is by means of a triangular shape, by converting the surface into a connected triangle, will be interacting with the machine. So it is STL stands for standard triangulation language. So this is one typical diagram which shows the STL file. So the STL file, it will convert the surface, the surface which connect the edge into the meshed triangle, the connected triangle. So these are some of the example how the STL file look like. So you can see the multiple triangles which are connected together, which actually represent the surface of a component which you have modeled in CAD. So after modeling in a CAD software, you can save the file as STL file format. The STL file will look like this. This is another format. If you look into this file, you can also relate this file with finite element analysis. In finite element analysis, we will divide the CAD model into a finite number of elements. Right? So the same procedure we are adopting for STL, but in FPA, we will be dividing a model, and in each element will be representing material property as well as the other property required for mass properties required for finite element analysis. But in this case, we are just representing the connected element, connected triangles. So I can say the STL file and mesh file is almost similar, but in mesh you can go for different shape, but STL predominantly it will convert your surface into a connected triangle. So let us all can see a video of how to save a STL file in a CAD software. So this is a window of a SolidWorks software. Let us take the CAD modeling is done, and we are going to convert the CAD model into STL file. So once the CAD model link is over, you have to go to save as. So instead of save, you have to go to save as. Once you go to save as option, you click into the drop menu, you can see different file formats. So these are all different file formats which you can use to transfer the CAD data for a required application. There is a step format which is required for finite element analysis. Parasolid format, again it is suitable format for finite element analysis. So most of the CAD software will support the STL file which is shown here, STL. So save the CAD model in the format STL. Now, the STL option is selected in drop menu. Directly going for save the model, you can click on the option in dialog box. So there is an option. On the option, you will be getting the another dialog box. So in this, it will ask for multiple input requirement. The first input requirement is binary or ASCII, because we are going to transfer the CAD data to a machine. So obviously it will convert the CAD data into a programmable, readable program. And again, this program will be read by the machine interface printing, layer by layer printing. So in which format you want to save? If you want to save in binary format or ASCII format, you know the difference between binary and ASCII. The programs will be in terms of ones and zero if you use a binary format. In ASCII format, you may have hexadecimal values as well as you can have an alphabet. So if you open the saved STL file in your program, you could able to see the word, you could able to see the vertex. The program will have a vertex 1, vertex 2, vertex 10, because it is going to convert the surface into a connected triangle. So each triangle will have a vertex. So the vertex name and number of vertex and the value for respective vertex, that is at which position the vertex is there with respect to coordinate. So all these things are readable in ASCII format, whereas in binary format, vertex and position of a vertex and relationship between one vertex to another vertex, clockwise or anti-clockwise, everything will be stored in zeros and ones. So ASCII will be readable, but at the same time, computational time will be more. The size of a file will also be more. Binary will be very difficult to read, but computationally it will be less. So that is the input. You can select in any form, and both the form are acceptable by additive manufacturing machine. But only thing is, if you want to do read for any other purpose, or if you want to do some modification through a program, then again you have to be very cautious in giving the format. The next process is solution. That is, I'm going to convert a surface into a connected triangle. So some software will ask you the value, whether how many triangles you required, or by means of some slope value, you can define number of triangles. In this SolidWorks, you have only three options: whether you want to have very fine triangle or very like post triangle or in between. So that you have to define. So the preview you can based on the resolution what you are going to give, the number of triangles. So what it does, it actually convert the surface which you have created in a CAD into a connected triangle. So if you change custom, you can define your own value. So you can see that the number of triangle got reduces. Very rough and very small triangle. That will reflect on file size also. As you increase the resolution, it became more fine and the file size will also increase. Obviously, the machine will get more data if you have a very fine text. You can see the file size. So defining this parameter based on the accuracy or based on the complexity you are dealing with is highly important, and you should be familiarized with this parameter. Sometimes you may not get a required dimension what you have done in CAD model. You cannot just blame the machine alone. You should be very cautious with respect to the parameters what you are defining. Uh, uh, save in save as format in CAD software. So that is about the STL file, how to save a STL file in a CAD software. We'll continue with our presentation. This is what we have seen in a video. So most of the software will support a different file format or interface. STL format is available in software. But only thing is, certain software you should have a separate license to see the STL file. As I have shown in the previous video, you may not do if you do not have a license to view a STL file. So if you want to do edit or to view a STL readable module, or otherwise there are a lot of high-end software available exclusively for STL file editing and STL file view. Now, if you look here, as I mentioned in the video, if number of triangles are more, then obviously the accuracy will be. How to define the number of triangle? In some software, you can set coarse, fine, or medium, and you also have an option for custom. You can define your own triangle value. Certain software, it will ask for a chord length. For example, in this case, the 2D cross section of a sphere is shown here. When I convert the sphere into a STL file, it will approximate the curved surface into a connected triangle. You can see the closed view of this STL file contour here. So if you look at the closer view, the orange line is your actual surface. But any STL file, when you are trying to convert a curved surface into a STL file, it will have an error. You can minimize the error. You cannot eliminate it because we cannot make a triangle with a curved edge, but you can minimize the error. This minimization of error can be done by a geometric form called chord height. So we all know the chord height. What is chord height? When a line is drawn on a circle which cut two point in a circumference, then the particular line to a circumference maximum height is a chord height. So if your chord height is very less, then the edge which is about to cut, the chord length is, if it is very less, then the size of a triangle will also decreases. That is, the cutting point will also decrease. And if the cutting point decrease, obviously the triangle, because this is one edge of a triangle. So if the value decreases, the angle distance also decreases, and that distance will reflect on other two edge of triangle. So obviously the triangle size also decreases. So you can adjust the size of a triangle, or you can improve the resolution of a STL file by defining this chord height. This is the case in uniform edges, because if you look into the sphere, almost all edges will have same height, or you can give a uniform value. But if you have a complex feature like this, right, so you may not get a same chord value. So if you define a chord value, and for each surface or for each region, the same chord value will end up with a different size of a triangle. So you may not get a uniform triangle, but as per the value whatever you have defined, it will create a chord height, and based on the chord height, it will give a one edge of a triangle. From that edge, you could be able to create a multiple triangle. So this is the another critical point in uniform based curved surface and non-uniform based curved surface, and that is the reason getting a different size of a triangle in this case. If you look into this figure, the triangles are not a uniform size, but if the surface are perfect, in this case there is no error at all, and you may get a uniform triangle at entire CAD. So this is about how to define a STL file for your uh, additive manufacturing part. Okay, so this is the first part. Now the second part is, why do we require a STL file for additive manufacturing process? So far what we have learned, what is STL file and how to save a STL file, how the STL file will look like, and what are the parameters you have to take care when you create a STL file. The next part is, why do you require a STL file for additive manufacturing process? So to understand that, you can see this image. Just I have created three models. Let us take a first model. The first model is a CAD. It is not a STL file. It is a CAD model. So directly I am transferring the CAD model to the machine. What does the machine will do? The machine will convert, it will slice the CAD model into n number of layers, and each layer will be printed in a machine. So when I supply a direct CAD model to a machine, the CAD model will have only edges and the surface connecting the edges. So when I slice the CAD model into n number of layers, you can see at each intersection. For example, the blue color line is a plane. So it is a virtual plane, because all this activity we will be performing in a software, not in a physical slicing or physical cutting operation. So virtually, the CAD model will be sliced in a software. So the slicing will be done in a such a way that it will create an imaginary plane which is parallel to the table or bottom edge, and this plane will get intersect into the edges of the component. So the CAD model will have only two edges. When this edge are getting intersected with the plane, the intersection point between the imaginary plane and the model edge will be obtained through a calculation in a software. So this the position of first intersection point, the position of second intersection point will be sent to the machine, and machine will go to the particular position. Machine will also have a 0,0 position. From this interface, the machine get to know that the first point is at 2,2, the second point is at 4,2. So what it will do is, the machine nozzle will go to, from the origin, it will go to 2,2, it will deposit a material. Then the second information is at 2,4, it will go to 2,4, it will deposit a material. So if instead of a CAD model, if I have a STL file, what is STL file? It is conversion of your surface into a connected triangle. So here I have used only two triangles. So if I have two triangles, this triangle will have three edges. So if I have a triangle, or if I convert a CAD surface into a connected triangle, I didn't do any dimension change. STL file will represent a surface in a connected triangle. So in such STL file, if I make a same virtual cutting, the plane will get intersection at 3 points: first point, second point, and third. So this 3 point data will be sent to the machine, and the machine will deposit a material at 3 points. So what what will be the scenario if I have many number of triangles? For example, in this case, this is also STL file, which is obtained from same model in STL file format. But this STL file have many number of triangles. So in that case, if I make a virtual cut, the machine will get 1, 2, 3, 4, 5, 6, 7, 8. So there are 10 intersection point, right? The first model will have only edge information. The STL model will help you to get the information between the edge, and those information will also be transferred to the mission. So mission will go to the specific position, whatever you got interface. In that position, it will deposit the material. So this will be repeated layer by layer. If you have only CAD model, the machine will get information only on skeleton, so that it will deposit a material only for a skeleton. If you save the CAD model into STL file, the machine could be able to get multiple points within the edge, and all these points are transferred to the machine as a coordinate. So the machine will go to the particular coordinate, and wherever you have a cutting intersection point, in that cutting point it will deposit a material. So this will be repeated layer by layer, because you are going to slice into n number of layers. You are going to divide a CAD model into n number of slices. So each slice will have an intersection point with the edge as well as the STL edge what you have created, and all those data will be transferred to the machine. Then that data will be used by the machine for material deposition or material joining. Finally, you could be able to get a three-dimensional model. So this is the critical importance of STL file. This is the reason why STL files are required for additive manufacturing process. A STL file helps you to get information between the edges, and this information is highly required for layer by layer addition of a material. So I hope with this image you all could be able to understand the importance of STL file for additive manufacturing process. The next point is, so this is a simple intersection formula. You know the plane equation. So plane may have some equation ax plus by plus ez is equal to constant. And if there is a line, because every point is going to get intersect with the line, it might be a line edge or the edge what you have created in STL. So substitute the point in the equation of plane. You could be the xy. If it is 2D, you could be able to get the intersection point in xy. If it is a 3D, you can get the intersection point at x, y, and z. So the last part of this session is data problem with STL. So there are three important problems with STL file. The first problem is data redundancy, repetition of data at multiple points. Topology problem. Topology problem is how the surface are represented. For example, the image which I have shown here, you may not get a connected edge properly if you are going for very complex component. When you convert a complex surface into a STL file, you may not get a proper connected triangle. So that is another critical problem. This problem might be because of topology or because of geometry. So we'll see. First problem is data redundancy. When I have a STL file, for example, this is a STL file. So if you look into triangle 1, triangle 2, there is a line which is common between triangle 1 and triangle 2. So when I save this STL file in form of a program, the vertex of triangle 1, that is this edge and this edge, is also a vertex for triangle 2. So the second edge will have the same vertex information as that of first. So that is the critical issue in terms of data redundancy. When you have 1 lakh triangle, each of this triangle will have two vertex in common. And if you take a particular vertex may be shared with, for example, this vertex is shared with this triangle can be shared with a particular vertex. So the same information is repeated at multiple times. That leads to high file size. So that problem could be avoided by using some algorithm. So that is one critical problem in terms of STL file in the point of data redundancy. The second problem is topology problem. So when I create a STL file and if it have very a complex surface, and if I try to convert the complex surface into a connected triangle, you may not get a normal vector at same direction, because when you want a connectivity from one edge to another edge, you should have a normal vector at same direction. If there is an inverted normal vector, and the file may not read properly by the machine, you may not get a appropriate information. So it is another critical issue. In that case, the STL file may not generate the triangle, or it may generate a multiple triangle which get overlapped. And this problem is because of a topology. If the surface, because most of the additive manufacturing process we are using for very complex component, and in certain case we will be doing a reverse engineering. So if it is a general CAD model, there is no issue. You may have very simple shapes. But if it is a complex CAD model, I'll show in a video with a complex model. So in that case, there might be a problem in terms of normal vector generation, and this problem leads to overlapped triangle or multiple edge triangle. So we may not have a normal vector, and this leads to a degenerated or flipped triangle. This has to be corrected manually. Some software have an automatic algorithm where you can fix this error. The another important geometric problem. For example, when I try to create a triangle for a surface, I may have thousands of triangles. So if suppose if you take from this triangle to this triangle, let us say the length is of 1 mm, and this triangle is already get connected by another triangle, and that also have a length of 1 mm. When I try to share a single vertex with a multiple triangle, each triangle will have a length, and the length value will have some decimal place. That is, it may not be exactly 1.00. It depends on the decimal place what you are using in programming interface. If more than 3 decimal are not captured, or if after 3 decimal the value may differ from one edge to another edge, you may not get a same value. So this accumulation of the geometry value leads to unconnected triangle, and this will also lead to error. So this problem will happen because of decimal value error for each triangle length. When I have a chord length, or if I give a triangle value, that according to the value given, it will keep on generated triangle for a surface. So when the decimal value error can keep on accumulate, and this will lead to the major problem at certain point, and that region will may not have a proper triangle connectivity. So this will also lead to flipped and overlapped triangle. Let us see in video this will be addressed.
Object,
This
more accurately about its
problem
surface, which is created by triangles. If the model has more details,
so this is a CAD model which are generated using a reverse engineering method. So generally, this is not same rectangles. So this has to read, and then software automatically will hide it, and then you can by manual correction.
also has more
This
triangles.
is another example where you have a overlapped triangle and missed triangle. So in some set triangles are connected properly, in certain region you may not have a proper issue.
A lot of modern slicers can partially fix some problems automatically, but if you do it by yourself, your model should fix when it is not solid. It means there are some missing triangles. Slicer can repair smaller issues, but you need to do that on your own if there are some bigger errors. You can also find objects which were created from parts that were designed separately. Because of that, here you can find double faces. Models can also have triangles flipped inwards. Slicer therefore can't recognize the surface properly and will create a problematic G-code. Objects should not have small amount of triangles if you don't want to have your model blocking. Errors can make slicer illegible to read the STL file, problematic G-code, or printing issues. Make printable works automatically. After
So these are the different way in which you can generate a triangle, and you can overcome the issues which are associated with the triangle. And I hope in this lecture you all could able to understand the need of STL file and how the STL file will look like, and how to save the STL file in a CAD software, and why we require STL file for additive manufacturing, and what are the problems associated with STL file and how to repair this problem. So we'll close this lecture with this discussion, and the next lecture we will discuss about the third step in additive manufacturing process, that is arc orientation. Thank you.